Hello, my name is David Hill. I'll be interviewing today, or I guess submitting my mock trial tutoring call for Crimson Education. And we're going to cover today systems of linear equations and also how that relates to systems of linear equations with quadratics, if time permits. I don't want to move too quickly. So without further ado, we'll get started. I'm going to share a whiteboard here. Hopefully you can see this on your screen. Okay, great. So let's get started today with systems of linear equations. We're going to start with some basics. Let me ask you right now, I don't know if you're familiar with this or not, you may be. Do you know how to solve systems of linear equations at all? Do you know the two most common methods people use? Yep, substitution is one, and this is my favorite. Elimination, yes. Substitution and elimination are my two favorite methods. Well, elimination is my favorite. Substitution and elimination are the two most popular methods. We're going to cover both of those today to make sure we understand those foundational concepts before we move on to more challenging problems that you may even see in the SAT. So, with that being said, let's start with substitution. If I gave you a system of linear equations, let's say it was 2x. I should click the marker. 2x plus, okay, let's say 3y is equal to 20. And the other equation was 4x minus y equals 10. How can we solve this systems equation using substitution? Okay, so substitution can be solved, first of all, in a variety of ways. You can substitute for either y or for x, and we can do that in both equations. So I'll do one example here. I'll take the bottom equation, for instance, and I'll isolate y in that equation. To isolate y, we should add y to both sides of the equation. So they'll put the positive y over here. And subtract 10 on both sides of the equation, which puts a negative 10 over here. Okay. And so what ends up happening is you have 4x minus 10 is equal to y. Okay. Now, why is helpful for us? Why does that matter? Well, that now allows us to plug in this value for y, 4x minus 10, into the other equation. Now I'm going to stop here for a second. A lot of students find this kind of confusing. They're like, why can I take a y from the bottom equation and use that value to plug into the top equation? Well, the solution to a system of linear equations is what? That's right, the intersection, right? The intersection of the lines is the solution. And at that point of intersection, we'd agree, hopefully, that the x's and y, the x coordinate and y coordinate, are the exact same on both lines, right? At the point of intersection, both lines have the same x coordinate and the same y coordinate. And because that is true, whatever value of y I get in the second equation, I can use that same value in the first equation, and then vice versa, because we understand that they're the same y value and the same x value at that particular point, which is what we're solving for. And so what I'll do here is I'll plug in 4x minus 10 into this y in the top equation, which now makes the top equation, if we were to clear the whiteboard here, 2x, okay, and it was plus 3y here, but now instead of 3y, we're doing 3 times 4x minus 10 in parentheses, replacing the y with what we define y as, and that equals 20. Now at this point, it's simple algebra, right? That's all this is. This is just an algebra. This is an equation with one variable. We just distribute 3 inside here. If we distribute 3 inside, this equation would simplify to 2x plus 3 times 4x is 12x, right? We can combine like terms, and that gives us what? What does that give us? Yep, 14x. Very good. And then what? 14x minus 30. Exactly. You are correct. Very good. Perfect. And now at this point, we have 14x minus 30 is equal to 20. How do you solve from here? Yep, you're absolutely right. Add 30 to both sides, and then we divide by 14. Right? Adding 30 to the both sides of the equation gives us 14x is equal to 50. And then dividing 50 by 14, to simplify that, make it a little nicer, we can do what? Yeah, they're both even numbers precisely, so we can go ahead and divide by 2. Exactly. We can divide both the top and bottom of the fraction by 2, which leaves us with 25 over 7. That is the value of x. Now, for the sake of time here, I'm not going to actually plug in the value of x into the function, but I do want you to understand that once I have this value of x, I can now take that value and plug it into the function for x, of course, and now solve for y, right? I mean, the hard part is kind of over at this point. We're just going to take the value of x that we just got, put that in the function, and now it's just a one variable function, right? It's just what we did just now. It's just basic algebra, right? And so what it ends up being, I'll just show you when we solve it out here. But we can plug into the top or bottom equation to be clear. So plugging into the top equation would be 2 times 25 over 7. That's the value of x, right? That plus 3y is equal to 20, right? And so now it's just an equation involving y that we definitely can solve. And then again, because the point of intersection contains, or rather has, the same x values on both lines, we know that we can plug 25 over 7 into the bottom line as well. So it's going to create 4, and then in parentheses here, 25 over 7. There you go. And then minus y is equal to 10. Okay. And so you can solve either one of these equations for the value of y, and then ta-da, you're done. Right? So that's substitution. Substitution is, I think, a little bit more intuitive for students, but it's definitely algebra heavy. I hate algebra. I know that sounds crazy because I'm a math tutor, but I don't like algebra. Okay, I kind of prefer to do as little algebra as possible. I tell students the best way to avoid algebra mistakes is to stop doing algebra, right? The less algebra we do, the better. And so, and the way that involves a little bit less algebra, in my opinion, is elimination. And so how do we do elimination? What can we do? So we actually do the same exact system of equations. We can just keep the same numbers. So you can kind of see how we'd solve both of these problems. And so I would take, again, 2x, 2x plus 3y is equal to 20. And 4x minus y is equal to 10. Using elimination, we can eliminate either the x's or the y's, okay? Substitution can be done in 4 ways. We didn't do all 4 ways, but just to make sure on the same page, substitution can be done in 4 ways. We could have did the same exact thing, but instead with the y in the second equation, we could use the y in the first equation, or use the x in the first equation, or the x in the second equation, right? So you can kind of substitute in 4 ways. Elimination is done in 2 ways. Either eliminate the x's or eliminate the y's. So I'm going to choose here to actually eliminate the x's. I don't have to do it that way. I'm just going to choose to do that. And so how do I do that? How do I eliminate the x's? Well, we can multiply both sides of an equation by any number that we want to, right? And so if my goal is to eliminate the x's, what number can I multiply the top equation by to get the same coefficient on the x's? Think about that for a second. Let me ask that question again. What number can I multiply the top equation by to get the same coefficient on the x's in both equations? 2, right, exactly. Multiplying both sides of this equation by 2 will make the top equation actually what? Yep, 4x, very good. And then what, 4x plus 6, right? Bingo. Yep, perfect. 4x plus 6 is equal to 40. You are right. Very good. Now, I can actually subtract the equations from one another right now. Just subtract right now. I mean, that's allowed, right? We can subtract equations, we can add equations, there's nothing wrong with that. And what this does is going to make this problem a lot easier for us. 4x minus 4x is what? 0x, right? That's why you call elimination. X is now gone, they're eliminated. Kind of like a video game, I guess, right? Negative y minus 6y is, yep, negative 7y, very good. And then 10 minus 40 is, Yep, negative 30. And so what happens here is you get negative 7y is equal to negative 30. This is basic algebra here. We only have one variable. And so to solve for that, right, you divide by negative 7 and you get, as you said perfectly, yep, y is equal to 30 over 7, right? And so yeah, that's the value of y. And similar to substitution, once I have the value of y or x, doesn't matter, I plug it back into either equation. It does not matter. Once again, it doesn't matter. I can plug in 30 over 7 into either equation and get the value of x here. Okay. So that's basic substitution and basic elimination. All right. Now, what we're going to talk about next, okay, is how we can, I guess, especially for the SAT or ACT, either one, and the questions get a little bit more challenging than this, how we can keep these same ideas in mind as we deal with more challenging systems of equations. So, first of all, what are the possible solutions to a system of equations? Let's just talk about that. What are the possible solutions to a system of equations? Again, the solutions are, you're correct, exactly the intersection of the lines. So, of course, we have one solution, right? They can intersect at one time. That's possible. Okay. Can you intersect twice? Can you have two lines that intersect twice? You sure? Two lines can intersect twice? Want to try and draw that out, maybe, and see if they do? I want you to draw that out and tell me if you can make two straight lines that intersect twice. Yeah, right, we can't do that, right? Two straight lines cannot intersect twice. So one solution is possible. We also could have 0. Yep, exactly, very good, right? So two lines that never intersect. What kind of lines never intersect? Remember that? So this is probably like back in 8th, 9th grade math. What kind of lines never touch? Parallel lines, yes, parallel lines, yep. And parallel lines have the what? What's the relationship between their slopes? What's the relationship between slopes of parallel lines? Not opposite reciprocal, that's perpendicular, right? Opposite reciprocal are perpendicular lines. They're the same slope. Yes, the exact same slope is parallel lines. Very good. So we have one solution, we have 0 solutions. Are there any other possible number of solutions? Think about that for a second. Any other possible number of solutions? You said 2 doesn't work. If 2 doesn't work, you probably could guess 3 is not going to work either, right? So this one here is a little bit harder to think about. There's actually infinite solutions. We could have a system of equations with infinite solutions. And of course, we have a system of equations with infinite solutions. Oh, I messed up my infinity sign there. That was really bad. Sorry. There we go. If you have infinite solutions, what that means is these lines are touching all the time, right? They're touching like at every single point on the graph, which means these two lines are what? The same. Yes, the exact same line, right? Only the same line can, two of the same line, I mean, can have infinite solutions. Very good. Now, why is this helpful for us? Well, because on the SAT or ACT, either one, I've seen more in the SAT, so I keep saying that, but also using the ACT as well, they will typically ask you at least one question, sometimes two, about a system of equations in which one of the coefficients is not a coefficient, but actually a variable. Yeah, it's kind of challenging, right? But it's actually not that bad. It seems challenging, but it's not that bad. Okay, so let's do an example. So imagine if we had a problem, and the problem said a times x plus 4y is equal to 8. Right? And then said another equation could be like 2x plus 8y is equal to 16. And the question reads, what value of a would create a system of equations that has infinite solutions? So we've already established that infinite solutions for a system of equations must mean the two lines are the exact same. It has to mean that, right? So given that we know these two lines are the exact same, it's actually a pretty fast, quick way we can do this and save ourselves some time. We know that they're the same line, that the coefficients and the number, the constant by itself, have to be multiples of one another. So notice here that 8 times 2 is 16. Yeah, and 4y times 2 is 8y. Good catch there, very good. And ax times 2 must therefore be 2x. So is a 1? Right, a must be 1. Because if a is 1, that means the first line is the exact same as the second line. They're just multiples of one another, it's the same thing. And that means that these system of equations, this system of equations would have infinite solutions. Perfect. Very good. Okay. Here's another example. What if it was like kx plus, I don't know, 6y is equal to 10. And then we had plus 3y here equaling, who knows, 30. And then we have 4x here. And this problem said, what value of k would produce a system of equations with no solution? Once again, we've already established that no solution means that the lines are parallel, which means the slopes have to be the same, exactly. And the slopes are the same, what does that mean for us? Well, in fact, if the slopes are the same, the ratio of the coefficients must be the same, right? So what that means is, we can see that 3y times 2 is 6y. For the same logic, that means 4x times 2 must be 8x. And so k therefore must be 8. Right? So you kind of see this is similar to elimination. It looks similar to elimination a little bit, right? So we can use this on the SAT and save ourselves a lot of time instead of trying to write these equations both in your classical slope-intercept form and then equating the slopes. We can just use the fact that, you know, these lines and rather these coefficients are multiples of one another and to solve that problem. So it's very similar to kind of elimination. So yeah, that's all we're gonna have time to cover today. So thanks for being here, really appreciate that. Any questions I can answer for you right now? And this is all new, but it's a definitely important strategy. So any questions I can answer for you right now? No, we're okay right now? Okay, well, I want you to keep practicing this. I'm gonna send you some homework after this call from the College World Question Bank website, and also some other questions I have found regarding this particular concept, and we'll make sure you understand that for your future test. Okay? All right, man, have a good day. Thank you for being here, appreciate it.